Hello viewers, my name is Deepti Mukherjee. Welcome to my channel. Today's topic is Principle of Mathematical Induction. A proof by mathematical induction consists of the following two steps. First step, show by actual substitution that the theorem is true for n is equal to 1. Second step, assuming the theorem to be true for n is equal to m, prove that it is also true for n is equal to m plus 1. First example, prove by mathematical induction that the sum of the first natural numbers is n into n plus 1 by 2. That means we have to prove that solution one plus 2 plus 3 plus n is equal to n into n plus 1 by 2. We have to prove. Here, when we put n is equal to 1, when n is equal to 1, LHS is equal to 1, RHS is equal to 1 into 1 plus 1 by 2 is equal to 1. That means first step proved. We put n is equal to 1 and LHS is equal to RHS is equal to 1. That means first step proved. Now second step. Second step, we assume that it is true for n is equal to m. Also true for n is equal to m. That means assume that it is also true for n is equal to m. Now that means 1 plus 2 plus 3 plus m. Second step, this is 1 plus 2 plus 3 plus 4 plus dot dot plus m is equal to m into m plus 1 by 2. And we have to prove that it is also true for m plus 1th term. So we have to prove it is also we now show that it is also true for n is equal to m plus 1. For this, at first we can write 1 plus 2 plus 3 plus 4 plus mth term plus m plus 1. That means at first we write down this, solve this, and then this is equal to m into m plus 1 by 2 plus m plus 1 m plus 2 by 2 is equal to m plus 1 m plus 1 plus 1 by 2. This is also true. That is, if m plus 1 is something like p, q, r, s, anything, then it is p into p plus 1 by 2, which is the theorem. So, proved. It is also proved as we put m is equal to m plus 1. We put n is equal to m plus 1. So, which is the same as given result for n is equal to m plus 1. Which is the same as n is equal to m plus 1. Proof. In this way, we can also prove some more example. Now, example number 2. Next example is prove by mathematical induction that 2 to the power n greater than n. Let Pn is the given proposition. P1 is true. 2 to the power 1 greater than 1 or 2 is greater than 1. Here, for 2 to the power m greater than m. Now consider 2 to the power m plus 1 is equal to 2 to the power m into 2. 2 to the power greater than m, that is greater than 2m. m is equal to m plus m. Or we can say, or 2 to the power m plus 1 greater than m plus m, and m plus m is greater than m plus 1. So 2 to the power m plus 1 greater than m plus 1. Proved. Hence, Pm plus 1 is true. Therefore, by induction, Pn is true for all n. That's all.